Okay, for part 2 of our lesson on bearings, we've got the example 4 and example 5 to go through, which are a little bit more involved. So example 4 creates a trig problem that we have to solve. It doesn't say there's a trigonometry problem in there, but if we start sort of putting it together, we'll see that there's a trigonometry problem involved. So the first thing it says is we've got Jesse's walked south for 2.8 kilometres. So we're going to create this point O and say that's his origin. That's where he started from. And so if he started from there and he walked 2.8 kilometres south, well, south is straight up and down. So this distance here is 2.8 kilometres. And then he walked west for 4.1 kilometres. So if we think about that, well, west and south there at 90 degrees to each other. So he's gone west a little bit further than he went south. So we're going to draw it in like that. There we go. So he went west 4.1 kilometres. Now we know that this angle here has to be 90 degrees because we went south and then west. These two, the main compass positions are all at 90 degrees to each other. And then it says, what's his true bearing from his starting point? So this is where he is now. This is where Jesse is. And we want to know from where we started, what's his bearing. So essentially what we want to know is I'll draw in the sort of a line linking up where he started to where he is now. And I'll get rid of my ruler out of the way now. So what we really want to know is we want to know the bearing in here. So that if we draw ourselves a north line here, what we want to know is this angle here. And that'll give us a bearing. So obviously, rather simply, obviously, the very first thing we know is that this bit here, well, that's 180 degrees. So if we can just find out what the angle inside that triangle is, then we'll be golden. So essentially what we're really saying is this here is this angle up here, that's our theta, that's the angle we're interested in. And now what we've got is a right angle triangle problem. We've got a situation where we have two distances and we want to find an angle. With reference to that angle, over here, this side looks like it's opposite that angle. And this side over here looks like it's adjacent to that angle. So I've got a trigonometry problem where I have an opposite and an adjacent side to consider. So I would use, I think of SOHCAHTOA, SOHCAHTOA, T-O-A, tan is the opposite over the adjacent. And I'll just write that down. So just start by going tan theta equals the opposite over adjacent. And then we start filling in the things we know. Well, what we don't know is the angle. So we'll leave that size as it is, but we do know that the opposite is 2.8. Oh, sorry, not 2.8, 4.1. And the adjacent is 2.8. So in order to find theta, we're going to have to use that 10 to the minus 1 button, the one that finds angles. So 10 to the minus 1 of 4.1 over 2.8, and we'll run that through our calculator. So shift 10, 4.1 over 2.8. There goes Faith. And we will close our brackets there. We get an answer, and that gets us 55. Now it says to the nearest degree, doesn't it? 55.6 degrees, so that's going to be approximately 56 degrees. Now, that's not our answer. Really important. The question was, what was his true bearing? All we've done is we've just found this angle in here. So we need to go a little bit further. So we say something like, therefore, the true bearing equals 180 degrees plus theta, which is 180 degrees plus 56. And that's going to equal 236 degrees. So that's our true bearing of that point. So really important that you read the question and draw yourself a picture. It doesn't sound like a question, a trigonometry question when you read it, but it's when you write it out, you realise that trigonometry is the way you're going to have to solve the problem. Okay, so that's an example of where we've taken bearings and we make a trigonometry question. The next question is not so much trigonometry, but just some real difficult stuff with regards to bearings. It's probably at the higher level of what you would be expected to understand with bearings. I think it was pulled from an old HSC paper. And so we'll start with the first part, which isn't too bad. Question A is asking, so we've got, really importantly in this question is that line there, because everything I do from here on in sort of relies on that. So we've got a bearing of E from D is north 38 degrees east. Now that's given there in the question, and it's in the diagram there. There's 38 degrees and there's 38 degrees. F is east of D. There is nothing written. It looks like F is east of D, but there's nothing written in that picture that says it definitely is. So make sure you read your question. And then it gives us this angle DEF up the top here. So to find the angles of X and Y, well, clearly this is some complementary angles there. Complementary angles are angles shared on a 90-degree angle. So they add up to 90 degrees. So therefore, X plus 38 degrees is going to equal 90 degrees. So X is going to equal 90 degrees minus 38 degrees. That's going to be 52 degrees. Okay, it only says the value of X. I don't need a bearing. It didn't actually ask for a bearing. It just said what's the value of X. So the value of X is 52 degrees. So the value of Y, now we've got a situation where once we know X, we know this 87 up in the top. What we've got is a triangle. So we know that 52 degrees, which is X, plus 87 degrees, which is up the top there, plus Y, has to equal 180 degrees. Okay, so Y is going to equal 180 degrees minus 87 degrees minus 52 degrees, and we can plug that into our calculator to work that all out. So 180 minus 87 minus 52, and we end up with 41 degrees. So once again, not a bearing, it just asked us for an angle. We've found those angles now. And for B, we're given what is the compass bearing of E from F. So the compass bearing of E from F. I'm sorry if I repeated myself there. I had to cut out what I've done. I made a little bit of an error. So what we're interested in with a compass bearing, we started either north or south and headed in the direction of east or west. So clearly this, when we're talking about this bearing here, we're closest to north. We're interested in this angle in here. So heading from north in the direction of west. Now, if I call that little angle there M, that'll do for now. M is just going to equal 90 degrees minus Y, because Y was, those two will add up to 90 degrees, because if F is east of D, then D is west of F. So this angle in here will also be 90 degrees. So to find M, we just do 90 minus Y, which is 90 degrees minus 41 degrees, which is going to equal 49 degrees. So therefore the compass bearing is going to be north 49 degrees towards west. Okay, then moving on to part C, it's pretty much the same sort of question. We're still at F, we're still looking towards E, but now instead of being interested in the little angle there, we're interested in this whole angle around here. Now there's two ways to go about that. You could work it out by saying, well, 360 minus M, or we could work it out by going 270 plus Y, because it's 270 degrees around here to the east-west line, and then it's another 41 degrees up to that line, or we could say it's 360 degrees all the way around, but we'll take off this last part at the end. So I'll do that as sort of an option 1 and an option 2, so you can see both ways work out the same. Just leave a little line there between them. So for option 1, we could say it's 360 degrees minus M, which is going to be 360 degrees minus 49 degrees, which is going to leave us with 311 degrees. Or we could say it's 270 degrees plus Y, which is 270 degrees plus 41 degrees, which is also 311 degrees. So either way there works perfectly fine. Now, something I didn't have with this question, which I think would make it harder, is actually to say, well, what's the bearing of F from E. Now, this hasn't been asked, but I'll just give it to you as an example. Remember, whenever you've got a point here like E, you can always draw a north-south line. Okay, at that point, we've now got parallel lines we could use to find this angle in here. We could, I'll put a little mark there. To find this little blue angle in here, it would be co-interior to M. Or to find this pink angle in here, well, that would be co-interior to that 38 degrees. So you could use that way to find out other angles and then therefore work out bearings in that spot. So if you're asked a bearings question where there is no north line there, you can always add a north line as long as it's parallel to the other north lines that are in the question. And that will get us through bearings. Good luck with all of that, and we'll tomorrow head into some stuff that you probably haven't seen before.